Okay, so let's start with a question that it feels like it belongs in a philosophy class, but it's actually going to anchor some really hard physics for us today.
All right, I'm ready.
If you look at a building way off in the distance and it looks tiny because it's far away, do you assume the building physically shrank?
No, of course not. That's just, I mean, that's perspective. It's just a visual trick of the eye.
Right, it's visual. We get that, intuitively. We understand that distance changes how things look, not what they fundamentally are.
Yeah.
But what if I told you that for the last 100+ years, the absolute bedrock of modern physics, and I'm talking about Albert Einstein's special relativity, the whole
A
thing,
whole edifice.
might be making that exact mistake?
Well, that's a huge claim. I mean, it sounds almost heretical to even say it out loud.
It does. It really is. But we've got a stack of documents here for this deep dive that aren't just, questioning Einstein. They're auditing him. And I use that word very carefully. We are looking at a space-time audit.
And this audit isn't coming from some crank on a forum, right? The source material is definitely unconventional. It's this mix of PDFs, very technical blog posts, and even these transcripts of an AI analysis.
Right.
But the argument itself, it claims to be mathematically rigorous. It's really proposing a full-on paradigm shift.
And we're talking about something called the unit circle model, or if you want the formal name, geometric information phase relativity.
Which is a mouthful, but the concept behind it, as we'll see, is surprisingly elegant.
So the core premise is this. Einstein told us that if you go fast, time literally slows down and objects literally shrink, physically. The entire universe warps around you.
Right. It's a physical deformation of reality.
And the documents we're covering today ask a really simple question. What if the universe isn't warping at all? What if we're just, looking at it from a weird angle?
Exactly. What if time dilation and length contraction aren't these magical physical changes happening to the cosmos, but they're just lag? What if it's just information latency?
That's the mission for today's deep dive. We are going to unpack this. We've got a lot of ground to cover. We have something called the camera eye, the unit circle, rotating pencils, and an AI persona called the independent space-time auditor that reads the theory and essentially puts Einstein's work on trial.
And the verdict from that AI is what makes this so compelling. It's a really dramatic conclusion.
So yeah, buckle up. We're going to try and dismantle the magic of relativity and see if we can replace it with plain old simple geometry.
Let's do it.
So let's jump into the setup. The documents all start with a scenario that, anyone who's taken high school physics is going to recognize. The observer in the train.
You can't discuss relativity without a train. It's the classic laboratory of the mind. It's almost a requirement at this point.
It really is. But this source material, specifically these documents, they label radius 9 and 11, and the line train document, they set it up differently. We have an observer, but they're at a fixed position, x equals 0. And they call this observer the camera eye.
And that name, camera eye, is so crucial. It's not just a poetic choice. In standard physics, we talk about reference frames, right? And they're these abstract, almost godlike coordinate systems, infinite grids where we somehow know where everything is at all times.
That omniscient view.
Exactly. But a camera eye implies something very specific. It's recording information, and it's recording it from a single specific point in space. It's not everywhere at once. It has a lens.
Right. And usually when we measure a moving train, we care about distance. We'd say the train is 100 meters away, or now it's 50 meters away. We'd think in terms of like rulers laid out on the ground.
Standard kinematics. Yeah, linear distance over time. But the unit circle model says, stop. That's your first mistake. If you are a single point observer, a camera eye, you cannot directly measure distance like that.
Why not?
Because all you can measure is angle.
Okay, walk me through that. Why does angle matter more than distance?
All right, imagine you're standing on the side of a highway. You're not holding a radar gun or anything. You're just watching the cars. A car appears way down the road on the horizon. It's coming right at you. How does it look?
It just looks like a dot. It's barely moving left or right in my field of view. It's just getting bigger.
Right. You're looking straight down the road. The angle of that car relative to your direct line of sight is almost 0. But as it gets closer, and specifically as it's right in front of you and passes you, what do you have to do to keep watching it?
Whoosh. It just flies by. I have to whip my head around to track it.
That whip around, that's the key. That is angular velocity. The car might be going a constant 60 miles per hour. Linearly, its speed hasn't changed at all, but rotationally, relative to your eye, Its speed went from basically zero rotation to a massive, massive spike in rotation as it passed you.
Okay, I can totally visualize that. The speed of the car didn't change, but my perception of its speed, the work I had to do to track it, changed completely based on the angle.
Precisely. This model argues that this rotational tracking, this movement of the eye, is the fundamental way we experience and measure motion. We live in a universe of angles and rotations, not just straight lines and rulers. And this is a point the source says standard physics often ignores, what it calls the observer's pivot.
The observer's pivot.
Yeah, we treat the observer as this static dot on a graph, but in reality, a real observer is a tracking mechanism. Your eye, your head, a telescope mount. It has to pivot.
So we are shifting from a ruler-based universe to a protractor-based universe.
That is a perfect way to visualize it, and that leads us directly to the core concept, which is the unit circle. The source also calls it the information radar.
This part took me a second to wrap my head around, but I think I've got it now. The source asks us to imagine a transparent sphere all around us.
Yes, a perfect sphere. And the radius of this sphere is defined by the speed of light, CA-Joe.
But they do something really clever with the units here. Usually, 10 1/4 of the speed of light is this enormous number, 300,000 kilometers per second. It's a speed limit. It's a number we plug into equations.
It's a velocity. But in this geometric model, they treat 7 as a radius. Specifically, they say, let's just define the radius of our sphere as 1 second.
So the unit circle isn't a circle of a certain number of meters. It's a bubble with a radius of 1 light second.
Exactly, 1 light second. And this is profound if you really sit with it for a moment. It means that the surface of your reality, the screen you are watching the universe on, is always 1 second away from you in terms of information travel time.
So if I look at something that's 300,000 kilometers away, like the moon roughly, I am seeing it as it was 1 second ago.
Correct. And if you look at your computer monitor a meter away, you're seeing it as it was a few nanoseconds ago. But the point is, you are never seeing now. You are trapped in the center of the sphere. The now is you, the center point, but all the information you receive about the universe is always arriving from the surface of the past.
The source material describes it as being inside an information sphere. We can't see the volume. We only ever see the shell.
We only see the shell, and that shell, that surface, creates the geometry of everything we perceive. This is the radius they keep talking about in those documents. If you accept that you are always looking through this time radius, then all the math of how things appear to move has to change. You can't just draw a simple straight line between two events and say, that's the distance.
Because you have to account for the curve.
You have to account for the curve of the time delay because you aren't measuring where the object is right now. You're measuring where the signal from that object was when it hit the shell of your sphere.
Okay, so there is a fundamental gap between the event, where the train physically is, and the observation, which is when the light from the train actually hits your eye.
Correct. And that gap, that delay, is what the source calls latency.
It's lag, like in a video game.
Precisely.
Yeah.
It's the perfect modern analogy. If you're playing an online shooter and the server lags, the enemy player isn't actually where they appear to be on your screen. You shoot at the image, but the player has already moved on.
And this theory is essentially arguing that Einstein saw that lag. He saw all the weird visual distortions caused by the lag, and he didn't call it lag, he called it relativity.
He thought the game server itself was warping. He thought the rules of the game were changing in real time. He didn't realize it was just a high ping. He looked at the distortion caused by the signal delay and assumed the entire universe had fundamentally changed its shape to accommodate the weirdness he saw.
That is, wow. Okay, that's the claim. But that's a huge claim. We need to back that up. Because Einstein's theory is famous for predicting things with incredible accuracy. You can't just say, oh, it's lag and walk away.
No, absolutely not.
You have to prove that lag produces the exact same math as warp space.
You have to show the math. And this brings us right to our next segment, dismantling the magic. Specifically, let's talk about length contraction.
This is the pencil thing.
Huh?
I absolutely loved this analogy in the documents. It feels so simple and tangible.
It's so simple, but it just completely destroys the mystique.
So, the standard story we all learn, Einstein says if a train moves fast enough, close to the speed of light, it gets shorter, physically shorter. If it actually hit light speed, it would be as flat as a pancake.
The Lorentz contraction. It's a staple of every physics textbook. Space itself compresses in the direction of motion, and there's a famous formula for it. $1 is L$ squirt 1 V2 C2.
Right. But the auditor in our document says, forget all that, just take a pencil.
Exactly. Hold a pencil in front of your face, hold it horizontally, parallel to your eyes. It looks its full length. Now, slowly rotate it away from you so the eraser goes back into the distance and the point comes forward. What happens to the visual length of the pencil?
It looks shorter. It's foreshortening.
Yeah.
It's like drawing 101. Basic art class stuff.
Okay. Did the pencil actually physically shrink?
No, of course not. I just turned it. The atoms and the pencil are all still in the same arrangement. Nothing changed about the object itself.
The unit circle model says that is exactly what happens to the train.
Okay, wait. I'm with you on the pencil, but the train isn't turning. It's moving in a straight line down the track. It's not, spinning like a baton.
But remember the camera eye. Remember the observer's pivot. Remember the angular velocity. As the train moves across your field of view, your relationship to it is rotating. You have to track it. From the perspective of the unit circle, which deals with the geometry of information arrival linear motion, is a form of rotation.
So there's a rotation of my gaze, of my perspective.
A rotation of the information vector. And here is the absolute kicker. The source material claims, and they show the mathematical derivation, that the formula for how short a pencil looks when it's rotated is mathematically identical to the formula for how short a train gets in relativity.
You mean the actual formulas match up?
Perfectly, 1-to-1. The formula for the tilted pencil's apparent length is simple trigonometry. $1 is $L is where Ferros is the angle of rotation. The formula for relativity is that Lorentz factor we just mentioned.
But those look completely different. One has a cosine and an angle. The other has a square root with velocities.
They look different, but the source argues that's because we've been defining speed incorrectly. If you define speed not as distance over time, but as a rotation on this unit circle, if you map velocity to an angle, then Lorentz is the Lorentz factor, scort 1v2c2. They are the same thing.
Hold on, let's really break that down. How does velocity equal rotation?
Okay, think about the unit circle again. It's a geometric tool. The radius is the speed of light, E082. That's the maximum boundary. In trigonometry, on a unit circle, what's the maximum value for sine or cosine?
It's 1. You can't have a sine or cosine greater than 1.
Right. So if you say that your linear speed, $5, is just some fraction of the maximum speed, light speed E082, you can map that fraction directly to a trigonometric function. The model proposes that the ratio of $0 is simply the sine of an angle, theta.
Okay, so if I'm going at 50% of the speed of light, my V's errors is 10/5. And you're saying that 0.5 is equal to the sine of some angle.
Exactly. Sin theta is 0.55. That corresponds to a 30-degree angle. And if you then use the most basic identity in all of trigonometry, the Pythagorean identity, sin theta plus come in fi few, you can solve for the cosine.
But if you do that,
You find that cotheta is exactly equal to sin theta. And since we define sin theta as $5, that means cos theta is equal to squarto 5 sedero.
whoa! So Einstein's magical shrinking factor is just the cosine of the angle of observation.
That is the core claim of the entire model. The Lorentz contraction is a trigonometric identity in disguise. Einstein's magic is just the geometric foreshortening of an object that is rotating through our information field.
That implies that the math of relativity isn't wrong at all. It's been completely misinterpreted.
The math works. That's why GPS works. That's why particle accelerators have to account for it. The numbers are absolutely correct. But the story we tell about what the numbers mean, the story that space itself is physically squishing, is unnecessary. The audit argues that we are confusing a visual rotation for a physical contraction.
It's like seeing a shadow get longer as the sun sets, and thinking the person casting the shadow is physically stretching.
That's a great analogy. Exactly. We are mistaking the projection for the object. We are measuring the image on our retina or on our sensor and assuming the world itself has deformed to match that image.
This has to lead right into the definition of speed itself. If motion is really rotation, does that change what speed fundamentally means? Because I've always thought of it as distance over time.
It fundamentally redefines it. In the documents, there's a whole section on this, on angular velocity, which is represented by the Greek letter omega omega.
This is the neck snapping thing again, tracking the car.
It is. The source argues that inertial frames, which are the holy grail of relativity, these frames of constant non-accelerated motion, are actually just frames of constant rotation of gaze. If you were tracking something moving at a steady pace across your view, your eyes are rotating smoothly and constantly.
So if I'm in a spaceship watching another spaceship fly past at half the speed of light, I'm not measuring its linear velocity. I'm experiencing a specific constant rate of rotation in my view.
Yes. And what happens if that spaceship goes the absolute speed of light? What happens when via equis? When
Right.
theta equals 11, so sin theta equals 11, and the angle where sine is 1 is 90 degrees.
90 degrees. You are perpendicular to it.
So at the speed of light, the object has rotated a full 90 degrees relative to my line of sight.
Yes. And what is the cosine of 90 degrees?
It's 0.
So the apparent length $1 there door is 0. The object appears to have 0 length. It disappears from your view, not because it vanished from reality or flattened into a pancake, but because you are looking at it perfectly end-on in a geometric informational sense. You can't see the side of it anymore.
It's rotated out of your frame of reference.
It has. That makes light speed sound less like a cosmic speed limit or a physical barrier and more like a geometric horizon.
It's the information horizon. It is the information horizon. You can't see past 90 degrees. You can't see behind your own ears without turning your head. Light speed is just the edge of your perceptual screen. It's the limit of the unit circle.
And this must connect to the Doppler effect too, right?
Yeah.
The documents were very clear that this model explains redshift and blueshift without needing time to stretch or space to warp.
Oh, this is one of the coolest parts of the whole theory. Usually, we think of the Doppler effect like sound. You hear an ambulance coming, the siren is high-pitched knee, it passes you, and it's low-pitched. Ow! WW! The sound waves get squished in front and stretched out behind.
Right, compression and rarefaction.
But light is different. It doesn't have a medium like air to travel through. So Einstein had to say that space-time itself is the medium. He had to invent a fabric that could do the stretching and squishing.
But the unit circle model says,
It says, forget the fabric, just look at the angle. The effect is called aberration of the light. Imagine you're running in the rain and you're holding an umbrella. If you're standing still, the rain comes straight down on you, a 90-degree angle to the ground. But if you start running forward really, really fast, where does the rain seem to be coming from?
it feels like it's coming at you from the front. It hits you in the face. The angle of attack changes. I have to tilt my umbrella forward to stay dry.
Exactly. The source argues that when we see redshift from a star moving away from us, we aren't seeing light waves getting stretched by a warping universe. We are simply seeing the angle of reception change because of our relative motion. We are cutting through the information sphere at a different slant.
So the color of the light doesn't change because of some kind of time magic. It changes because of the geometry of the vectors.
It's just vectors. It's all just vectors and trigonometry. The light is the same light, but our intercept vector with that light has shifted.
I can almost hear I don't know if it's frustration or excitement
Right?
in the voice of this auditor character. Speaking of which, let's talk about this space-time audit. This is a recurring character in all the source material.
The AI auditor, yeah. It's a really fascinating narrative device to frame the whole argument.
The documents are written almost like a court case. The people versus Albert Einstein.
Yeah.
The judge is an AI.
Specifically, it's framed as an AI like Claude or Gemini that's been trained on all of standard physics. It's an expert in Einstein. And then it's exposed to this new unit circle geometry. The premise is, can an unbiased intelligence fed only logic and geometry determine which theory is better?
And it uses these scores. I found this both hilarious and really compelling. It tracks the belief level of the AI.
Right. At the start of the audit, the AI reports its confidence levels as Einstein's standard theory, 90% probability, and the new geometric theory, 0%.
Which makes sense. That's the standard consensus. The AI is just reflecting what it learned from Wikipedia and every physics textbook ever written.
But then, as the AI reads about the pencil analogy, the cosine equivalence, the aberration of light, the scores start to shift. It enters what it calls a reading phase, where it processes the line train document and all the math we've just discussed.
And there's this step 3 in the documents where it hits a perfect tie, 45% to 45%.
That's the tipping point. That's the moment the AI realizes, wait a second, both of these theories fit the mathematical data. Both of them correctly predict that the train will appear to shrink. Both of them correctly predict the clock will appear to slow down.
So if they both work mathematically, how on earth do you choose between them?
You pull out the oldest and sharpest tool in the scientific toolbox, Occam's razor.
The simplest explanation is usually the right one.
Exactly. The auditor looks at Einstein's theory and says, okay, your theory requires us to believe that space and time are flexible, physical fabrics that can warp, bend, stretch, and loop. That's a massive ontological commitment.
That's an expensive theory. It costs you a lot of assumptions about the fundamental nature of reality. It's a huge pill to swallow.
A very expensive pill. Then the auditor looks at the unit circle theory and says, Your theory requires us to believe that light takes time to travel from one place to another, and that things look different when you view them from an angle.
That's a cheap theory. I already know light takes time to travel. I already know perspective exists. I mean, I experience perspective every single time I look down a long hallway.
So the auditor rules in favor of the cheap theory. Why invent an entire physically warping universe when a simple error in geometric perspective explains the exact same data?
It goes so far as to call Einstein's theory mysticism.
Occult is the word it uses. It says that relying on unseen dimensions, warping and stretching, is akin to a magical explanation. It accuses standard physics of multiplying entities beyond necessity.
That is just scathing. But I get the logic. If I lost my car keys, and I had two theories. Theory 1, a goblin who lives in the walls stole them. Theory 2, I dropped them behind the couch cushion. The goblin theory could be true. It explains the missing keys perfectly.
It does.
But I should probably bet on the couch cushion theory first.
Einstein is the goblin theory. It's an amazing, intricate story that explains everything. The goblin took them, but maybe you just dropped them. And the unit circle is the floor where you drop them.
But wait a minute. Einstein isn't just about shrinking trains and slowing clocks. There's the massive issue of simultaneity. This is the part of relativity that always confuses people. The idea that two things can happen at the same time.
And this is our next segment, the simultaneity trick. This is where the AI auditor really goes for the throat and accuses Einstein of essentially cooking the books.
Okay, explain the trick. What's the accusation here?
All right. In standard relativity, Einstein was obsessed with this idea that the laws of physics must be the same for every observer, no matter how they're moving. If I see a light flash and you see a light flash, we should be able to agree on the physics of it in some coherent way.
Sure. That sounds like a reasonable starting point.
But the problem is the lag. It's always the lag, the unit circle. Imagine a long, fast-moving train. A light bulb flashes exactly in the middle of a train car. For the guy sitting on the train, he sees the light from that flash hit the front wall and the back wall of the car at the exact same instant.
Because he's moving with the car. To him, the train is stationary.
Right, but now think about the person standing on the platform watching this train fly by. From their perspective, the back wall of the train is moving toward the point where the light flashed, and the front wall is moving away from it, so they will see the light hit the back wall first.
They completely disagree on what now is. One observer says the light hit both ends at the same time. The other says, no, it hit the back first and then the front a little later.
Right. They have a fundamental disagreement about simultaneity. And Einstein's solution was to say, okay, in order to make the laws of physics work out for both of them, time itself must flow at different rates for each of them. He warped time itself to fix their disagreement. He forced a mathematical synchronization that wasn't there in the raw observation.
So what does the unit circle model say?
The unit circle model looks at the situation and says, they disagree, so what?
Laughs, deal with it. Is that the answer?
Basically. The source argues that Einstein skipped the procedure. He tried to force a universal now or a synchronized frame where one can't possibly exist. The physical reality is, light takes time to travel. The guy on the platform sees the back wall get hit first because the light traveling to the back wall had a shorter distance to travel to his eye. It's just geometry again.
It's just lag. The train moved, so the distances for the light paths change, so the arrival times of the information changed.
That's all it is. The source says we are always seeing a mosaic of different times. When you look at a moving object, you are seeing the back of the object from a slightly different moment in time than you're seeing the front of the object, because the light from each part took a slightly different amount of time to reach you.
You're seeing a time smear, not a single snapshot.
A time smear. And Einstein tried to unsmear it by warping the universe. The unit circle says, just accept the smear. The smear is the reality of observation. You can't synchronize the universe into one single now. You can only track the delays.
This has to connect to the Michelson-Morley experiment, the most famous failed experiment in history.
The experiment that broke 19th century physics and paved the way for Einstein.
They were trying to measure the Earth moving through a hypothetical substance called the luminiferous ether, the medium they thought light waves traveled through.
Right. They shot beams of light in different directions, one with the Earth's movement, one against it. They expected to see a difference, a shift, caused by this ether wind, and they found nothing. Zero, a null result.
It was a huge shock, and Einstein's brilliant interpretation was, that's because there is no ether. The speed of light is constant for all observers everywhere, period.
But the unit circle documents argue something much, much subtler. They argue that the null result is actually a geometric necessity, even if there is a universal electromagnetic field.
How does that work?
Imagine you're holding a flashlight and walking. The source of light, the flashlight, is moving with you. The center of your unit circle, your sphere of observation, moves with you.
Okay, I'm with you.
The source argues that because the measuring device itself, the interferometer, is moving inside its own geometric information frame, the delays on the round-trip journey of light beam cancel each other out perfectly. You cannot measure your own motion through the field using a round-trip light beam experiment because the geometry of your own observation bubble balances the books before you even look at the answer.
So the experiment didn't prove there is no ether.
Yeah.
It proved you can't measure your own drift using a self-contained light experiment.
Exactly. It proved that the unit circle geometry is robust. You are always, by definition, at the center of your own information bubble. The source claims Einstein misinterpreted the silence. He thought the silence meant nothing was there. The unit circle says the silence just means the system is perfectly self-contained and self-correcting.
This brings me back to the screen analogy again. The documents talk a lot about the observer's view as the retina, or a monitor screen.
This is from the section they provocatively title Einstein's laziness.
I love that. Was he lazy? Or was he just, I don't know, too brilliant for his own good?
The argument in the source is that he was lazy in a very specific way. He confused the render for the model.
Okay, use the 3D graphics analogy from the documents. It's a really good one.
Okay. You know a program like Blender, the 3D animation software.
Yeah, of course.
In Blender, you build a 3D world. You create a cube, a sphere, a train, whatever. That's the model. It has real, defined 3D dimensions. Then you place a camera somewhere in that world. The camera takes a picture, and that picture is what gets displayed on your flat 2D computer monitor.
That's the render.
Exactly. Now, if you take the cube in the 3D world and you tilt it away from the camera, what happens to the image of it on your 2D monitor?
It gets distorted. The square face becomes a trapezoid or some other skewed shape.
Perspective distortion. The source says Einstein looked at the 2D monitor, which is our retina, or our scientific instruments. He saw the cube get skewed, and he wrote a law of physics saying cubes physically deform into trapezoids when they rotate.
He confused the pixels on the screen for the atoms in the actual object.
He confused the map for the territory. He built an entire physics of appearance, of the representation, and he called it a physics of reality, of the measurement.
And the lag, the finite speed of light, is the reason the render looks distorted in the first place.
Yes, because the camera has a shutter speed, and that shutter speed is defined by $2. The image is always constructed from old light, from information that has traveled.
So if we want to know the truth about the 3D model, we have to reverse engineer the distorted 2D image. We have to account for the lag.
And if you account for the lag, if you do the geometric correction, you get the unit circle model. You get a universe that is stable 3D and doesn't warp. It just looks like it does from our limited single-point perspective.
This brings up a really important question about scale. If Einstein is wrong, why does he seem so right? Why does my GPS work? Why do particle accelerators and nuclear bombs work if they're based on his equations?
This is the macro versus the micro argument in the documents. And it's brilliant because it explains how both Newton and Einstein can coexist and both be right in their own domains.
Okay, right. Newton says space is flat and absolute. Einstein says it's curved and relative. Who's right?
The source says, it just depends on the size of your circle.
Explain that.
Imagine a macro world. A world where the radius of your information circle, the speed of light, is huge. For the sake of argument, let's say it's practically infinite.
If the radius of a circle is infinite, the circle is a flat line.
It's a straight line. In a world with infinite light speed, there is no lag. You see everything instantly. There is no angle of distortion because information arrives from all directions at the same time. There's no time smear.
And that's Newton's world, absolute space and absolute time.
Exactly. Newton beautifully describes the macro view, where the curve of the information sphere is so incredibly gentle that for all practical purposes, it looks flat.
But we don't live there. We live in the micro world, where dollars is very much finite.
We live close to the center of our circle. The
Right.
radius is only 300,000 kilometers per second. That sounds big to us, but on a cosmic scale, it's a very tight curve. The curvature is sharp.
So when we move really fast, when our angular velocity is high and we are rotating quickly along that sharp curve, we notice the distortion. We see the foreshortening.
And that's Einstein's world. He was the first to notice the effects of the curve, but he thought the world was curved. The unit circle model says, no, Albert, the world is flat and Euclidean. It's your viewing lens that is curved.
So the unit circle unifies them. Newton is the flat Earth approximation of the information sphere, and Einstein is the curved lens reality of looking through that same information sphere.
Precisely. It's one single consistent model that explains both Newtonian and relativistic behaviors just by changing one variable. How fast are you rotating relative to the radius of your information bubble?
That is incredibly satisfying. It cleans up the entire timeline of physics. It stops Newton and Einstein from fighting with each other.
It does. And in doing so, it removes the paradoxes that have plagued relativity for a century.
The twin paradox. Yes, we have to talk about the twins.
The source material is very explicit that this model dissolves the twin paradox completely.
So the classic story. One twin stays on Earth, the other gets in a rocket, flies near the speed of light, comes back, and is biologically younger than the twin who stayed home.
Right. In standard relativity, that's real. He is physically, biologically younger. His cells have aged less.
And in the unicircle model,
In the unit circle, he just looked slower. His information clock, the rate at which signals from him arrived back on Earth, appeared to slow down because of the extreme Doppler lag and the geometric angle. But physically, his metabolic rate didn't change one bit. He comes back, and they're both the same age.
all the science fiction writers who rely on that are going to hate this.
It completely kills the time travel to the future trope, but it saves logic. There is no paradox. There was just a really, really long-distance video call with a terrible connection.
Laughs. Sorry, you're breaking up over there. You look like you're moving in slow motion.
That's literally it. Your video feed is lagging, bro.
So we've audited the books. We've turned relativistic trains into foreshortened pentals. We've flattened the universe back out to something that feels Euclidean and intuitive. What is the final verdict from our AI auditor friend?
The final verdict in the documents is paradigm shift certified. The source material ends with the AI changing its belief score to 100% for the geometric model and 0% for Einstein's. It concludes that the unit circle is the superior model because it assumes less. It relies only on things we already know to be true geometry and the finite speed of light, not on a mysterious, unproven space-time fabric.
It feels humbler. It's a humbler view of the universe and our place in it.
It is. It puts the observer back in their place. We aren't masters of a warping universe that bends to our motion. We are just point observers, each of us trapped in the center of our own private bubble of light.
And that brings us to the closing thought for you to take away. And this one is a bit of a brain melter.
It really is. It sticks with you.
If this model is right, if everything you see, everything you measure, everything you think of as out there is just a projection on the inside surface of a sphere of light.
And you have to ask yourself a very fundamental question. Have you ever actually seen the universe?
Or have you just been watching a movie of the universe, a recording projected onto the inside of your own personal spherical bubble?
You're walking around in a private IMAX theater. The screen is always exactly 1 light second away in all directions, and everything that's playing on that screen is, by definition, history.
We are fundamentally disconnected from the now. We can never touch it. We can only ever see the wake it leaves behind on our screen.
And maybe Einstein's undeniable genius wasn't in describing the universe as it truly is. Maybe he was just the first person to perfectly describe the geometry of the IMAX theater.
He described the projector, not the movie itself.
That's the thought to take home with you.
Listener, thank you for taking this deep dive with us. It's been a trip of Radius 1.
Check your angles and watch your lag.
And we'll see you in the next one.
See you then.